Hello everyone, welcome back. Today we are diving into a fun and visual part of polynomials, their graphical representations. Understanding how a polynomial equations look on a graph helps us make a sense of concepts like zeros and roots. We'll explore plotting linear, quadratic and cubic graphs. Also, we'll learn the geometric meaning of zeros. So, let's get started. Let us begin by representing equations on a graph. Let's recall that any equation can be represented as a graph on a Cartesian plane. The graph visually shows how the values of x and y change according to the equation. For an example, y is equals to x is a given equation. On a graph, this is a straight line because for every point of x and y, graph passes through points like 1, 1, 2, 2, and 3, 3, which can be further plotted as this, and the graph looks like this. Another example, y is equals to 2x plus 1. This represents a straight line as well, but it starts at a point 0, 1 because at x is equals to 0, y has a value of 1. But as x increases, the line rises more steeply. Now, let us focus on linear polynomials. A linear polynomial is a straight line. The general form of a linear polynomial is y is equals to ax plus b, where a is also the slope of the line and b is known as the y-intercept. So taking an example, let us graph y is equals to 3x minus 2. This is the graph of 3x minus 2. So here the line will cut the y-axis at minus 2, which is a constant term, and the slope is 3. The slope 3 here is the meaning for every unit increase of x, y will increase by 3 units. It cuts the x-axis at a point which is also known as the zero of the polynomial, and in this case the zero of the polynomial will be 2 by 3. Next it is the quadratic polynomial. So the quadratic polynomials have a general form of y is equals to ax square plus bx plus c. So the graph of a quadratic polynomial is a parabola. It either opens upwards or downwards depending on the value of a. For example, if a is greater than 0, the parabola will open upwards like a U shape. And if a is less than 0, the parabola will open downwards like an upside down U shape. Something like this when a is greater than 0, and if a is less than 0, it is like this. Let us take an example, y is equals to x square minus 4. So in this simple quadratic equation, the value of a is 1, b is 0, and the constant term c is equals to minus 4. So the graph will be a U-shaped parabola as a is greater than 0. Something like this, and the parabola will cut the x-axis at 2 points, that is minus 2 comma 0 and 2 comma 0, which are also the zeros of the polynomial, that are minus 2 and 2. Now let us talk about higher degree polynomials like cubic or other powers of x. For example, the graph of y is equals to x cube. This is a cubic polynomial and the graph will pass through the origin, that is 0, 0, and it has a distinct S-shaped structure. It lies in the first and third quadrants because the cubic function has an odd degree. That is, this graph will be similar to this. Now similarly, if you take y is equals to x power 4, so the graph will resemble a quadratic curve but the very steeper side. That is, it will lie in the first and second quadrants, and the graph will look similar to this. Now if we again take another polynomial, y is equals to x power 5. So in this case, the graph will be similar to the cubic one, but it will be more steeper than the cubic one. In the sense, the graph will be something similar to this. Now steeper in the sense the graph is more nearer to the y-axis. So this is x cube, this is x power 4, and this is x power 5. So while drawing these graphs or plotting these graphs, we use a general rule here for any polynomial x power n. So if n is odd, the graph will pass through both the first and third quadrants, that is first and third quadrants. And if n is even, then the graph will be entirely above the x-axis that we have seen in the case of x power 4. That is, it will lie in the first and second quadrants. So lastly, let us talk about geometrical representation or meaning of zeros of a polynomial. So what do these graphs tells us about zeros of a polynomial? Geometrically, zeros are the points where the graph intersects the x-axis. For a linear polynomial, for example, p of x is equals to 3x plus 4, the graph will cut the x-axis at minus 2. That means this polynomial has only one zero, that is x is equals to minus 2. Similarly, for a quadratic polynomial like p of x is equals to x square minus 4, the graph can cut at the x-axis at 0 points, 1 point or 2 points. Generally speaking, the graph can be either like this, or it can only touch the x-axis having only single 0, or it can intersect the x-axis at two distinct points. So in this example, the zeros or the roots of this given polynomial are minus 2 and 2. Similarly, for a cubic polynomial, the graph cuts at 3 points in this case. So this cubic polynomial can have a maximum up to 3 zeros, and the zeros are minus 1 comma 2 comma 3. And that is how you represent polynomials graphically. We have covered how linear, quadratic, cubic polynomials look on a graph. We have explored the geometric meaning of zeros. Understanding this makes solving polynomials much more easier. I hope you find this video helpful, and that is it for this video. I'll see you in the coming ones.